the kinematics study guide, kinematics being the mathematics of motion, looking at the idea of rates, and rates being how fast or how slowly something happens. We looked at two very specific rates in Physics A with kinematics. We looked at speed and velocity. Speed is the rate, and anything that is divided by time is a rate. So speed is the rate at which you traverse, cover distance, travel. Whereas when it comes to velocity, velocity is the rate at which you displace. And definitely displacement, something very different than distance. Displacement is your change in position, change in distance. It's your final position minus initial position. And anything that has this delta symbol simply means final minus initial. So it might look familiar to you. Change in pi is pi final minus pi initial. We're going to continue our investigation in kinematics and rates by looking at acceleration. Question here, what is acceleration? Well, I'll write the shortcut for you that you can write in your study guide in the full sentence, and then here in the study guide you can write the shortcut I'm about to write. So the shortcut expression, acceleration is the rate, so you have another rate. Acceleration is the rate at which I change velocity. Acceleration is the rate at which I change my velocity. So that statement is what you want to write here. Acceleration is the rate at which I change velocity. And then here you can write this expression. Acceleration is the rate at which I change velocity. A equals delta t divided into delta v. Now the units for acceleration, so this piece right here, my units, well, let's recall the units for velocity are meters per second with direction. So if there's no direction given, like on a compass system, north, south, west, east, then we typically are going to use that magnitude in the expression, that plus or minus going to let you know direction. So if you're on a grid, anything above your origin and to the right of origin positive, below and negative, but to the left of the origin. So plus or minus here meaning direction. The units for velocity are the meters per second in a direction. Let's continue working our units with time. So copying the division, and the SI go-to unit for time, we use seconds. So your SI unit for acceleration turns out to be meters per second per second. Or you can write that as meter per second, or meters per second squared. I tend to write the units more this form or this way. I tend not to write this one very often, surely because we don't really use seconds very much in terms of squared units of seconds. I haven't ever in my life told someone, oh, I'll be with you in about 25 seconds squared. So I try to avoid this to help ease confusion. Plus, I prefer to think of the units this way, and then they make a little bit more sense to me. That my acceleration is the rate of changing velocity. So acceleration, the rate in seconds or hours or years of changing velocity, a meters per second or kilometers per hour. For example, I could have units of acceleration, maybe kilometers per hour per second. Every second I change, increase or decrease by X amount of kilometers per hour. We'll look more at this relationship in a moment. In the study guide, it asks for you to show the work in determining the units for acceleration. What we're asking here is to take this and show how that does turn into this meters per second squared. So I'm just going to rewrite this over here, meter per second. And so meter per second, I'm just taking and writing this piece instead of horizontally, I'm writing it vertically. This division, I'm just going to write as division. This is your symbol for division because it's the divide bar right there. Then, hey, there should be a number there and a number there. And I'm dividing by the second, so I divide by that second. Now, in math, with fractions, can't divide. So we're going to use the partner of multiplication. So my meters per second times that inverse, sometimes reciprocal in math, so that inverse. So flashback to physics A, the inverse of the second, 1 over s, or you may recall that that is also a hertz. 1 over s, that is a hertz, 1 over s. All right, continuing back to the math, a meter times a meter is a meter, and a second times a second is a second squared. So the point of this in the greenish color here was to respond to this. Show the work in determining the units for acceleration. How does this become that? Right through that mathematical process. Right, just want to pause, make sure you have this piece in your notes. What you should be able to review and understand thus far is that acceleration is the rate at which you change velocity and has the units of meters per second per second. If you understand that much, life is golden. That is so far your take-home message. The next little thing I'm going to do with you in this bluish color is just bluish bonus. And this is just to impress your friends if you wanted to. So acceleration is, in fact, the rate at which you change velocity. We know that change of velocity is v sub f minus v sub I, and change in time, delta t, is t sub f minus t sub I. Velocity right here. I know that velocity is the rate at which I displace. So I could change this right here to a rate of displacement final. So I've just substituted this expression for the v and the final, and then subtract the initial velocity, t sub f minus t sub I. I'm just going to bring this down here because I could have way more nerdiness fun with mathematics that I know that displacement is from earlier final position minus initial position. So if I really wanted to go crazy, I could have d sub f minus d sub I divided by t sub f minus t sub I. This t sub f minus t sub I being that delta t written out. And all of that, of course, final. This final, that final. Just do the same thing for here. And we have d sub f minus d sub I over t sub f minus t sub I. That's my initial, kind of curvy. And divide by t sub f minus t sub I. That, my friends, is acceleration. Of course, all I want you to really focus on is acceleration is the rate at which you change velocity. This stuff down here is just, again, impress your friends. Acceleration is really made up of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 variables. Perhaps 11, 12, you want to consider that. So you've got at least 10 variables involved with acceleration. Now, I'm never in your physics class going to give you 9 variables and ask you to solve for the 10th. We are absolutely just going to stay with our expression here. And this in the blue bonus right here, that's just to show off your friends. This is what I want you to be focused on right now. Sadly, all the fun stuff has been erased, as I want to emphasize, what we're focusing on this class, acceleration is the rate at which you change velocity in the units of meters per second per second. That's what we're going to focus in on. That's what you'll want to understand. The other stuff I was showing you, the many other variables contained within these here, those are things that you would explore more detailed in and more practice with in an AP Physics class or an AP Calculus class, perhaps. All right, let's get back to our physics class at hand, acceleration, the rate at which you change velocity. Item C right here. What are the following changes in velocity called? So we're going to look more detailed at this aspect. Now, I don't mean detailed like we just did, but looking at the concept of changing velocity. I can change my velocity by going faster, okay, an increase of velocity. I can go slower. I can change my velocity by slowing down. And remember, velocity is all about vector quantities. So really my acceleration units definitely want to consider direction. Acceleration is also a vector quantity. We worry about magnitude, the number portion, and direction. Because of this direction aspect, another way I can change velocity is by changing direction. And I have no idea why. That's just the symbol I use to show change direction. Not something you would see in a textbook for sure. So I have 3 ways I can change my velocity. So there are 3 different avenues I could time to have a change in velocity that we call acceleration. And in fact, it would be much better served if right in here, what are the following timed changes? Very minuscule here, but very important to put in the study guide. What are the following timed changes in velocity called? So if I were to take my going faster and time how long it took me to go faster, how long I increased my velocity, that's an acceleration. Acceleration is the rate at which I change my velocity. So an increase in velocity, that's known as acceleration. If I were to time how long it took me to decrease my velocity, that's also an acceleration. Now, outside of a physics classroom, we probably would call that a deceleration. That's perfectly fine. But do recognize it's a form, or it's acceleration. It is timing going slower. And so this decreased velocity, yeah, we could probably put deceleration in there, and that's fine. But do recognize it is purely, it's acceleration, a timed change in velocity. And then if I change direction, if I time how long it takes to change the direction, that is acceleration. Acceleration is the rate at which I change direction. So that is acceleration. 3 different ways of manifesting a change in velocity. We have 3 ways we can consider acceleration. Meaning acceleration, we can think of acceleration as how fast I go faster. This will bog your mind. Acceleration is how fast I go slower. Acceleration is how fast I go faster. Acceleration is how fast I go slower. We have 2 rates. It's a rate of a rate, if you will. Hence, a rate of a rate, we've got 2 time components. And then, of course, acceleration is the rate of changing direction. Acceleration, how much time to change direction. All right, describe how the 3 pictures below demonstrate acceleration. The classic gas pedal, which more properly known as the accelerator pedal. The accelerator pedal, gas pedal, that is an acceleration in that we could time how fast we went faster. A steering wheel is a type of acceleration in that if we timed your change of direction, now of course not the Hollywood type of where they got the steering wheel and you jerk it so fast here, quick back here, but if we were to time your interval of changing your direction, that's an acceleration. So changing direction in a certain time, that is acceleration. The brake pedal, that is acceleration if you were to time slowing down. Brake pedal, it's acceleration if you were to time how long to slow down, which is a form of acceleration, so we could call that the accelerator. Might be a little disruptive in your driver's ed classes with your sophomores and such if we called both of these the accelerator. All right, letters E and F. Letter E. Describe the acceleration of an object moving in a circular path at a constant speed. Circular path, so moving at a constant speed. Let's say my constant speed is 8 meters per second. Describe my acceleration. Acceleration is the rate at which I change velocity. Alright, so there are 3 ways to change velocity. I can go faster or slower, 2 most common that we tend to think of. Well, with saying it's a constant speed, and there's no 8 meters per second here, I just put a quantitative value down. Not going faster or slower than 8 meters per second, we quickly want to say, oh, that's no change in velocity, so therefore no acceleration. But remember, vital to acceleration, because it's a vector, is changing direction. If I'm moving, even if it's a constant 8 meters per second, my magnitude isn't changing, but my direction is changing. Maybe north is to the left, and so I'm moving towards north. Now I'm going south. Headed north, now I'm going south. So I'm changing my direction. If I time my changing a direction, if I time changing direction, which is a change in velocity, then I do have acceleration. Letter E. Describe the acceleration object moving in a circular path at a constant speed. Because the object is moving at a constant rate, there is acceleration because of the change of direction. So even though moving at a constant speed, I should say, there is acceleration because of the change in direction. Letter F. Describe the velocity of an object when the acceleration is 0. Most of us before this class probably thought of acceleration as just going faster. Well, going faster actually is velocity, because velocity can be going faster, slower, or changing directions. If I time these changes, then I get acceleration. So thinking about that, the question here of letter F, acceleration is 0, we'll just say meters per second per second. If my acceleration is 0, we tend to think not moving, no motion, because 0 meters per second. But as we are starting to see the importance of considering velocity changes as timed changes in directions can be acceleration. So back to this idea of moving at a constant 8 meters per second, I'm changing my direction. I do have an acceleration on letter E. Letter F, an acceleration of 0 doesn't just mean it's not moving. Now it certainly can. It can mean object not moving, or in physics we often will say at rest. But the goal here to realize, as we are focusing in on these changes in directions that are timed as accelerations, we have to recognize that an acceleration of 0 also could mean something moving at a constant rate without changing direction. So over here, we were changing direction at a constant rate, and there was acceleration. Here we're saying there is no acceleration when moving at a constant rate without changing direction. So that is not an object moving, an object not moving, sorry, or something at rest. So something, a box sitting on a floor or table, just sitting there, of course, acceleration of 0. But what we're also saying is this motion of the pen, if I were to do one grid line every second, so if I were to start here and go 1001, 1002, 1003, 1004, 1005, 1006, 1007, for those 7 seconds, I didn't go faster, okay? I did not increase my velocity. I did not decrease my velocity. Nor did I change direction. So that means there is no acceleration. Yet there was movement. I was moving, but I was moving at a constant velocity. So we could shorten this up to say that this is something moving with constant velocity. And this velocity, not meaning speed, velocity of vector meaning no changes in direction. So an acceleration of 0 means something's not moving, like you probably thought of before you came to physics. But also we need to recognize that it could be an object moving, but with a constant velocity. So once again, if I just did one square or one line of the square per second, 1001, 1002, 1003, 1004, 1005, for those 5 seconds, that had no acceleration. Now, yes, of course, starting out right here, where I wasn't moving and started the pen moving, that's acceleration. And the ending, where I was moving and I stopped, there's acceleration. But for this interval in between, there was no acceleration. Really, I should say grid lines per second for each of those 5 seconds. All right, from the top on this letter E and F. Describe the acceleration of an object moving in a circular path at a constant speed. Even though the object has a constant speed, a set magnitude that doesn't change, the fact that you're changing direction and timing that means there absolutely is acceleration. So an object moving in a circular path does accelerate despite a constant magnitude because of the change in direction. Letter F. Describe the velocity of an object when its acceleration is 0. When an object has an acceleration of 0, it could be at rest, or it could be moving with a constant velocity, meaning I'm not going faster, I'm not going slower, nor am I changing direction. So acceleration of 0, you can have motion.